In this lesson, we're going to learn about building and comparing confidence intervals. So first of all, what is a confidence interval? It is the range of plausible values for a parameter. So remember, a parameter is just that value that describes the population that's usually unknown. So we're going to look for plausible values for this. It's a point estimate plus and minus the same amount. When we say point estimate, what we mean is either the sample mean of an unknown population mean or a sample proportion. It is always the center of a confidence interval. So when we take this sample and we calculate either the sample mean or the sample proportion, that is how we build and create our confidence intervals. The plus minus amount in a confidence interval is known as the margin of error. This determines the width of the interval. You might see margin of error in different texts or online referred to as the ME or the MOE for shorthand. And then we have what's called the confidence level. This is the level of confidence you have in the confidence interval that you've created. It is the probability that the unknown population mean or proportion falls within the confidence interval. And a special note here is in order to create a confidence interval for a population mean, the CLT conditions must be met. So this means that the sample must be at least 30. Let's look at a couple examples. Number 1 says, we do not know the mean amount of rain that Bloomington Normal gets in May, since we do not have a record of all rainfall during May since the very beginning of time. Suppose that we want to estimate the population mean, mu, by using a sample of data that was recorded. So we do have some record of the rainfall in May, but only back to a certain date. So we can use that as our sample. Let's say in this sample, again, this is totally made up, but let's say that the mean of the sample was 3.8 inches. So that's the sample mean, that's X bar. And the margin of error in this sample was 0.3 inches. It says construct a confidence interval for the mean amount of rainfall for Bloomington Normal in May and explain what this interval tells us. So this is how a confidence interval is built and how it's written. It's written with parentheses, like from a lower value to an upper value, the range of plausible values. The lower value is calculated by taking the sample mean minus the margin of error. And then the upper limit is calculated by doing the sample mean plus the margin of error. So that creates your range of plausible values for the population mean. In this case, we have all of the numbers we need. The sample mean is 3.8 and the margin of error is 0.3. So we just say, okay, for the lower limit then 3.8 minus 0.3, and for the upper limit 3.8 plus 0.3. And those are fairly simple calculations, so I'm just going to do those. That is 3.5 for the lower limit and 4.1 for the upper limit. So that's our confidence interval. What does this tell us? It tells us that the mean amount of rainfall in Bloomington Normal for May is likely between 3.5 inches and 4.1 inches. So this is the range of possible values. Based on these calculations, we believe that the overall mean amount of rainfall for Bloomington Normal in May for all time is somewhere between those two values. And just as a special note here, notice that the X bar value, the sample mean of 3.8, is right in the center of the interval. That always is the case. That sample value, that sample mean or proportion, is always the center of your interval because your interval is created by going minus and plus from there. So a lot of students get confused or they feel like that is something special that they need to talk about, but it's actually not anything special. That's just true for all of them. So it's just kind of, that is the feature of how these intervals are created. It says now in number 2, suppose instead that you begin with a confidence interval and you want to work backwards to determine the point estimate. So again, that's either the X bar or let's say the P hat and the margin of error. So that plus minus amount. This says, suppose for the month of April, we have an interval that has already been created. Someone already created to us and they present it to us for the mean amount of rainfall in Bloomington normal as between 4.2 and 4.7. So someone calculated that. What if we want to work backwards and figure out, well, what was the sample mean X bar in this case, and what was the margin of error? That's where this idea of X bar being the center comes in important. So if we remember that X bar is the center of the interval, basically what you want to do is find the middle or find the average of the lower and the upper limits. So I could calculate that by saying, well, what's 4.2 plus 4.7 divided by 2? That's 8.9 divided by 2, which is 4.45. So that's X bar. We found part of what we want. And then we can use the idea where we started in number 1. If you look kind of where I'm up making marks. Remember that to find the lower limit, we were doing X bar minus the margin of error, and to find the upper limit, we were doing X bar plus the margin of error. So we can say then that to find that margin of error, we would take our point estimate of 4.45 and subtract 4.2 from it. How far down did we go? We went down 0.25. As a check, I'm going to make sure this checks out. If we also go, if we also figure out what's the difference between the upper limit of 4.7 to 4.45? Like how far is it from the upper limit to the middle? If you subtract that, you also get 0.25. So because these two match, I'm confident that my margin of error is 0.25. You don't have to do both of those calculations for margin of error. One, either finding the difference between the center and the lower limit, or the upper limit and the center. They should be the same distance. I just did both to check myself that my work was correct. So giving this as a visual, for you visual learners, what this interval looks like then is I'm going to put 4.45 right in the center. 4.2 is down here. That's my lower limit. 4.7 is up here, my upper limit. And what we're saying is that the margin of error, the distance on both sides, is 0.25. That's the plus minus amount.